Okay, let's just jump right in. Imagine for a second that you could peer directly into the underlying source code of existence. Pretty wild, right? Today, in this explainer, we're investigating a model where the entire universe functions as a massive computational network. But we're not just looking at it humming along perfectly. We're actually looking at what happens when it hits a critical, reality-breaking error. And the craziest part? We're going to see how an emergent mechanism, something you literally interact with every single second of your life, gravity, actually acts as a cosmic software patch. It swoops in to save the very fabric of reality from just falling apart. Welcome to the temporal glue. Think about the basic sequence you need to build a universe. Particles have to cluster into atoms, atoms clump into dust, dust into stars, and, well, eventually into us. But what if the math running that whole sequence just stops working? In this computational model, instead of pulling together, the system aggressively rejects itself. It's like a universe trying to boot up, but crashing every single time. Everything pushes away. There's no structure, no matter, no galaxies, literally nothing but a broken, flat field of pure repulsion. So, what exactly is going wrong under the hood to cause such a complete and total catastrophic failure? Well, the theoretical data logs point us to a massive roadblock, formerly called the C2 real anomaly. To wrap our heads around this, you have to realize that in a computational universe, matter and geometry are not the same thing at all. They are two totally separate sets of data. You've got the matter field, which is the actual stuff of the universe, and the geometric field, which dictates the shape of the space that stuff lives in. For reality to actually function, these two data streams absolutely have to sync up perfectly. The C2 real anomaly is basically the universe's ultimate blue screen of death. It's a topological mismatch where the matter just cannot resolve into the geometry, and it creates this severe blockage that stops the universe from scaling up right in its tracks. Picture reality at this fundamental level as a giant interconnected web. The matter lives in what physicists call the vertex space, so the individual points or the nodes of the web. The geometry, on the other hand, exists in the edge space, the physical lines trying to connect those points together. And the root cause of our anomaly is right here. When these two distinct channels try to talk to each other, the math supporting the matter completely scatters the second it reaches the edges. The whole network just fundamentally lacks the internal tension it needs to align the dots with the lines. This total communication breakdown triggers a very specific glitch called the n=7 monotone failure. Now, n=7 just refers to a precise stage of complexity in the network's growth. But at this exact threshold, right when the universe is supposed to start building actual three-dimensional structure, the system gets hopelessly stuck. It turns into a completely flat computational field locked in pure repulsion. Because there's zero mathematical incentive for the data to cluster or close into a stable state, the energy landscape is just way too shallow to form a physical packet of reality. The universe essentially becomes a featureless void, endlessly pushing itself apart. No way, right? To really grasp the friction happening here, let's use a brilliant analogy. Imagine the universe's geometry is a winding mountain railway, and the data of matter is a massive, heavy freight train barreling down those tracks. Okay, so step one, the sheer weight of the train physically bends and banks the track over time. That's matter influencing space. Step two, the next train that comes along has to tilt precisely to survive that curve. That's space telling matter how to move. But step three, if a train comes in way too fast or the track bends too sharply, we hit immense mathematical friction. The vectors and spin violently misaligned. So when the train's motion and the track's twist don't align, that geometric friction threatens to derail the whole cosmic network. But the source material highlights something genuinely amazing. The system doesn't just blindly crash. It's actually incredibly resilient. It constantly calculates the error, and when it realizes the current geometric shape is mathematically impossible to sustain, it purposefully snaps the connection. It literally severs the link to forcefully rewire a new, stable geometric path. It acts as this vital survival mechanism, an ultimate pressure valve for stress that stops a localized error from corrupting the entire universe. This brings us to a massive revelation uncovered during the investigative simulations, specifically in the theoretical USS Gemini logs. When researchers first spotted the C2 real blockage, they honestly thought the simulation was just broken. But it wasn't a dead end at all. It was a perfectly accurate simulation of a universe actively crying out for a missing physical ingredient. The anomaly wasn't a bug in the code of reality. It was the precise, undeniable mathematical signature of missing gravity. Gravity isn't just an arbitrary force. It's the emergent solution the universe absolutely demands to stop itself from tearing apart.
So how exactly does the network generate this gravitational fix? It all comes down to a highly specific, derived structural constant, the Einstein coupling constant, or kappa. And its value? Exactly 1 over 9 pi squared. This isn't just some random number plugged into an equation. It represents the exact necessary proportional factor that balances the underlying lattice of space. To put it simply, it provides the perfect mathematical ratio relating the sum of the face-level curvature directly to the edge-level connection energy. It provides the exact amount of tension the universe desperately needs to pull those rebellious vertices and edges back into alignment.
Finding this vital constant is a real game changer. It allows the computational model to evolve from a broken, static architecture into a dynamic, functioning system. It does this by modifying the fundamental master equation of the universe's energy, which we call the Hamiltonian. By injecting this Einstein coupling constant into the Hamiltonian, we're effectively downloading a software patch called simplicial gravity right into our cosmic equations. This newly introduced curvature term steps in and acts like the ultimate cosmic traffic controller. Its whole job is to manage and resolve that dangerous geometric friction threatening to derail the system.
We can actually break down this updated master equation almost like a recipe. It's got 3 crucial ingredients working in tandem. First, you have the minus jk term. That's the base ingredient, the original flat computational field. Next is the chaotic spice, the plus lambda v term. That's the repulsive violation we talked about, causing the universe to aggressively push away from itself. And finally, we drop in our hero, the stabilizing binding agent, plus kappa times rk4. That is our Einstein coupling constant actively operating on the network's curvature, binding all that chaos and flatness together. The moment this equation goes live, the dynamic of the entire universe just completely flips. The contrast is really stark here. Before gravity, when kappa was set to 0, we suffer that agonizing n=7 monotone failure, just pure chaotic repulsion where absolutely nothing could form. But the second we inject that coupling constant, boom, we generate geometric attraction. The new curvature defect actually warps the network, creating a potential well that physically draws the scattered computational states toward a stable fixed point. Instead of pushing away, the fabric of reality finally begins to pull inward. This dynamic curvature fundamentally operates as the temporal glue. We call it temporal because it dynamically governs the evolution of space over time, taking that catastrophic topological mismatch and clamping it back into perfect, seamless alignment. By forcefully making the matter situated at the vertices agree with the geometry spanning the edges, gravity provides exactly the tension the network was missing. It's literally the ultimate bonding agent, making sure all the wildly complex, disparate components of reality finally sync up and work together.
Reality successfully routes around its own destruction. By physically bending space to absorb that mathematical stress, gravity completely resolves the n=7 structural failure. The variations in the framework and the connections achieve this beautiful, sustainable equilibrium. And that C2 real mismatch officially drops right to 0. Think about what this means for us. Because this mathematical glitch gets resolved, the universe isn't some repelling empty void. The network can successfully cluster, galaxies spin, stars ignite, planets form, and eventually we get the chance to exist and even ponder these very equations. We've seen exactly how emergent gravity patches the cosmic glitch, transforming a broken network into the vibrant universe we live in today. But, understanding this mechanism leaves us staring down a truly profound and provocative question about the absolute limits of our physical reality. We know gravity actively rewires the network to vent computational stress. But is there a critical threshold where that geometric friction becomes simply too vast for even gravity to hold? What would a total topological snap look like on a massive galactic scale? It's an incredible concept to think about as we continue to untangle the hidden logic of the cosmos. Keep observing, keep questioning, and keep exploring the code of our universe.